The 2D wall mill operation expands on the previous wall profiling operation and improves ease of use and performance. It offers a comprehensive graphical UI and provides an immediate display of a toolpath preview when changing input parameters. This way, the user does not have to rely on the final toolpath results to adjust the operation parameters. In this video, we will show various functionalities of the 2D wall mill operation in NXCAM and cover the following aspects. To create a 2D wall mill operation, navigate to Create Operation, set type to Mill Planar, and select the 2D wall mill subtype. Click OK to create the operation. Notably, for a 2D wall mill operation, no workpiece is needed to generate a toolpath. Click on Specify Wall Geometry, select a face of the workpiece and click OK. After selecting a tool, the toolpath can already be generated. At this point, there is no retract to the clearance area because by default an inherited clearance is used, but no workpiece is selected. The clearance option can be changed under Non-Cutting Moves, Traverse, to a specified or automatic plane. When the clearance is set to Automatic, navigating to Geometry and selecting Workpiece will optimize the toolpath accordingly upon regenerating. Accounting for the workpiece is useful because this way NXCAM can check and ensure that the tool does not collide with the workpiece. Under Main, Range Definition, the wall top and bottom can be extended by a specified amount. The extension distance cannot exceed 100% of the tool diameter for both parameters. Users should be aware that increasing these values may cause air cutting. For a 2D wall mill operation that covers multiple pockets, the sequencing of these pockets can be automatically optimized. The selected sets of wall geometry can be accessed by selecting Main, Specify Wall Geometry. By default, the order of execution is based to the user-defined order in this dialog. Navigate to Strategy, Cut Order. Here, region sequencing can be changed to Optimized. This will calculate a toolpath which minimizes non-cutting motions, visualized as red dashed lines. There may be instances where users do not want to use a single 2D wall mill operation to machine an entire wall, especially when there is more complex geometry involved, like with this workpiece. In the Main tab, the range type can be changed from Automatic to Specify. Now, a wall top and bottom level can be set. These limit the range of the operation. In this first example, with the range limited to the fully cylindrical part of the geometry, we can generate a completely circular toolpath. Here, in this second example, the range specifications are once more very beneficial because due to this back wall, which extends far beyond the other selected walls, the automatic range type would result in a highly suboptimal toolpath. Another modification users can make to the toolpath can be found by navigating to Non-Cutting Moves, Start Points. By default, start points are set to the midpoint of a path. This can be changed so that start points are set the corner of a segment. Alternatively, by clicking on Specify Point, there is the option to set user-defined start points per region. Furthermore, users can extend the toolpath in multiple ways. These options can be found under Strategy, Extend Path. The option Overlap Distance applies for contours that are completely closed and refers to the short distance which is retraced by the tool to smoothly connect the start and end of the contour path. By default, it is set to 5% of the tool diameter. When changing the value, the new overlap distance can be visualized by regenerating the tool path. The extension distance applies for open contours, like this modified version of the previous example. By changing this value from the default 5% of the tool diameter, users can further extend the toolpath beyond the selected faces. Lastly, especially for walls with a bottom that is not flat, the toolpath can behave in two different ways. By default, continue cutting below tool contact is enabled. This way the tool moves continuously, which is typically the most desirable behavior. Alternatively, this option can be disabled, which results in a tool path that is contained to the area of the wall. Overall, the 2D wall mill operation addresses the need to generate toolpaths fast and to modify them for various applications, while offering an easy-to-use and learn UI.